Okay, in previous lecture, we are discussing about the how to measure the distance between two pixels. The main concept is how to measure the distance between two pixels. This is a topic we had discussed yesterday lecture. In this, to defaultly, there is the distance between the adjacent pixel is always one. The distance between the adjacent pixel is always one. How the pixel can be identified? The pixel can be identified by using the matrix. Well, how the matrix will be created? In MATLAB, if you insert any object, we read the object will be converted into the matrix format that will be stored in the variable. In this matrix format, the matrix can be accessed by using index value as 1, comma 1. We are starting from 1, comma 1, that is rows and columns. Here, the value which is stored inside the matrix, we can call it as a pixel intensity value, or we can also call it as a pixel brightness value. This value can be as the range from 0 to 255. The range will from 0 to 255. We are discussing about the black and white image. We are discussing about the black and white image. These are the things we are discussing yesterday. Now, just to give a recap of the different types of distance measure is Euclidean distance measure, city block measure, and chessboard measure. In Euclidean distance method means we are able to find the distance of a 2 pixels by the range of a radius. If you go for the city block distance measure means it can able to find the distance between the pixel by within the range of the diamond shape. Within the range of the diamond shape. If you go for the chessboard distance measures, we are able to find the distance of a square type. You can able to find the distance of the square type. In this way, we are discussing yesterday. There is a three formulas to identify, to define the, or we can find the distance between two pixels. One is Euclidean formula, one is city block formula, the next is chessboard formula. The Euclidean formula is x minus s square root plus y minus t square root whole square of to the power 1 by 2, where x and y is a coordinate for the pixel p and s comma t is the coordinates for the pixel q. Here we are considering the two pixels. We are going to find the distance between two pixels p and q. So the p as the coordinate x comma y, q as the coordinate s comma t. By using this formula, we are able to find the distance between two pixels. The next is city block. In this city block, we are going to find the distance between two pixels, p comma q, where the p is the coordinate x comma y and q is the coordinate s comma t. Here, there is a two lines will be drawn. This line you can able to tell that it refers as the absolute value. This two bar representing the absolute value. What is absolute value? The value should be in the positive. If I give minus 4, I am able to get the absolute value as 4. If I give plus 4, the absolute value of the plus 4 is also 4. Just will give only the positive number. Okay. According to the example, we are able to formulate this. Here p comma q, where p as the coordinate x comma y, where q as the coordinate s comma t. According to this diagram, according to this matrix, the p the pixel p will be represented in the form of coordinate 2 comma 2, and q is representing in the form of coordinate s comma t, that is 4 comma 4. Applying for to this formula, x minus s 2 minus 4 absolute plus y minus t, 2 minus 4. So here the answer is minus 2 plus minus 2. Minus 2 absolute value is plus 2, minus 2 absolute value is plus 2. So 2 plus 2, 4. We are able to find the distance of the pixel of the diamond position in the 4 locations. Okay. Now we are moving to find the distance between the another chessboard method. We can call it is to find as p comma q, where the pixel is p comma q. To find the distance between two pixels p and q, we are using the formula max of. Max means it is a function, it gives the maximum value. Absolute of x minus s, comma, absolute of y minus t. The absolute gives a positive number. In these two numbers, which is the maximum number, it will be given. Example, we can see max of x comma t, x comma s is nothing but 2 comma 4 is 2 comma 2 minus 4 comma y minus t is 2 comma minus 4. The result is minus 2 comma minus 2. It is absolute value of minus 2 is a plus 2. So maximum of 2 comma 2 we are able to get at 2. So the distance between this p pixel and the q pixel is the distance is 2. In this way, we are able to find the distance between any two pixels by using this formula. Okay. So we are completing how to find the distance between two pixels with formula. Now we are going to a new topic so that we are just stop sharing the screen. I'm sharing a new screen for the new topic. Kindly reply me in chat whether the PPT is visible to you. Yes, fine, Vijay. What about other? For others, the PPT is visible. Yes. Yes. Warkesh. Okay, fine. Thank you. Okay. Now, till now, we are discussing about what is meant by the digital image. Till now, we are discussing about what is meant by the digital image. Okay. Now we are moving up to this. We are discussing what is an image, how the image will be captured, how the image will be converted in the matrix, how the matrix can be handled. Everything will be discussed up to this. Now we are moving to the next part called image processing. Here the image processing is nothing but how the digital image can be processed. Process means how the digital image can be made some manipulation. Manipulation means doing some operations on the image. We can call it as the digital image processing. Till now we can see what is meant with a digital image. Now we want to perform some operations on that image. We can call it as a digital image processing. The operation may be, for example, for easy operation is just we can enhance the brightness of the picture. This is one operation. The complicated operation is just we can identify a small object in a particular image. This is an operation. So we are performing some operations on the digital image according to our desired output. We can call it as a digital image processing. In this digital image processing, it will be divided into three processes. That is to continue from image processing to the computer vision, meaning that capturing the image After capturing the image that should be transferred to the system, the system will able to perform some operations on the digital image. Can be as a three process. One is low level, mid level, and high level process. We can see one by one. What is the low level process? So each process we have the input and we have the output. Here in low level process, we're giving the input as an image. We'll also get as an output as an image. We're giving an image as the input. We are able to get the output of an image. Here, what are the process can be done means image sharpening and noise removal. The noise removal is nothing but unwanted information in the image can be removed. Image sharpening means just like adjusting your lens to get a focus, exact image. That is called image sharpening. Okay. This type of operations can be done in the low level process. So in image processing, we are divided into the three types: low level, mid level, high level. In low level, we are take the image, we are able to perform some operations like unwanted image will be removed, that is a noise removal, image sharpening. Then we are able to get the good picture. Okay, this type of image processing we can call it as a low level processing. We can see reduce the noise, reduce the noise, contrast enhancement, image sharpening. For this, there is no need of separate tool. In the Word document itself, there is an option to enhance the contrast, increase the contrast, reduce the noise. Image sharpening is everything in a built-in function in Word document. Okay. The next we are going to the next level. You can see as mid-level process. Mid-level process. In this mid-level process, we take an image. The output will be the attributes, a small part, a subset of the image to identify the object recognition, segmentation. So here we can able to see the images, take an image and attributes are extracted from the image. Attributes means subset of a particular image, a small part of the image like edges, contours, identity of the individual objects. We are not taking a whole, we can take the input of the whole image and we are able to process and we are able to take a subset of image, a small part of image like edges, individual objects. This type of operation we can call it as a mid-level process. This type of operation requires a special tool for the image processing. The final is high level process. The final is high level process. In this process, it takes the attribute as the input, where we will get the attributes output from the mid-level process. The attribute is nothing, only part of the image, subset of the image. According to some operations, we're able to get that object attributes. So high-level process take these attributes and output will be the understanding what we are looking for. You can able to see image analysis and computer vision. You can able to see if you go for the doctor, if you take the CT scan. Once the CT scan is taken, the image will be scanned, then we are able to take a small part of the image. Then from this small part of the image, we are taking on a particular part where the disease is affected. By taking this particular part, again we are going for the analysis, then you can able to understand that how much the disease is spread. This is the from low level to mid level and mid level to high level process. Okay. In this way, the digital image processing will be taken place. So in digital image processing, there is a 9 key stages in digital image processing. Each and every stage, different operations will be taken place. In digital image processing, there is a 9 stages. Each and every stage, the image can be processed in some methods or algorithms or some formulas. We can see method by one by one. Here we are going to see an elaboration only. Subsequent modules we are studying in the image processing. We are able to study each and every model separately, like image enhancement, image restoration, morphological processing, segmentation, recognition, representation. We're not studying about the image compression, then we are able to study about the color image processing. Okay. Now we can see the first stage. The first stage is nothing but we are capturing the image. We are capturing the image, that is called the image acquisition. Acquisition means capturing the image. The image can be captured by using a camera. We have already studied how the image will be captured. The image will be captured by its reflection. The reflection can be done by using the light rays. So a light rays will be passed over an object. The object can be reflection. Arrays, arrays. So it reflects. That reflection will be stored as an image external panel. That image will be converted into the digital so that you are able to get an image. So if we change the light source and angle of capturing image, the image output of the image is also changed. We can able to see if you take capture an image in your phone, in a sunlight, in dark place and semi-dark place, we are able to see the change of the image capture is also changed. That is, the output image also changed. The output portion of the image is also changed. So, image acquisition is nothing but capturing of an image. Image acquisition nothing but capturing of an image. It can be captured by using a camera. After capturing that image, it will be converted from analog to the digital image. The next is image enhancement. Here we are able to see an example. The image is enhanced by its depth. We are able to remove extra white colors so that we are able to see the image depth most clearly. This type of operation we can call it as a image enhancement. It is like sharpening, smoothening, and removing the noises. This type of called as the image enhancement. The next is image restoration. We're able to see clearly. It is an overview giving with an example to understand what is mainly image key stages. Okay, we are going to study each and every stage separately as a separate module with the different types of algorithms. In this unit 1, we are going to see the overview. Image restoration. This is the image. We are able to see a lot of noises is there. Small noises is there. I want to remove this noise. We can able to see the image is restored. If you go for the damaged image, then you're able to get a cleared image. That process we can call it as the image restoration. Morphological processing. It is used for the biometric operations. If we put the biometric, how this biometric will be changed in the digital form and it will be stored by using the operations. We are already clear that the image will be stored in the form of the matrix. In matrix, we are able to perform the operation of the addition, subtraction, multiplication, division. Other than that, we are able to do the operation called AND or NOT operation while performing the image processing. That we can call it as a morphological processing. The next is segmentation. It is most important. Here is segmentation. Here we can see this image. We have captured this image. It is a spanner where we are able to see there is some space should be there, some space should be here. To identify this type of operation, we are able to use a segmentation. This segmentation is very useful to identify the objects in a particular image. So it is mostly used for the identification of an object. Object recognition. It is most important that which type of object will be there. For example, if you capture any image, our software should tell that the image will be representing this object. If I capturing a mouse, our software to be tell that the captured image is a mount. So we will convert this image, the digital image in different angles. According to that, the captured image will be compared with the already previous stored images to identify which type of object will be there. Nowadays, it is a predefined software which is stored in our mobile phone. Most of the iPhones or high level mobile phones, we can take the picture, it automatically tells that which object is represented in the particular picture. The next step we can see that representation and description of an image. The next we can able to see representation and description of an image. This is nothing but to identify the edges, and after identifying the edges, we are able to represent which type of image and which shape of the image is. These are done in the high level process. High level process. I already discussed that low level, middle level, and high level. In high level process, this using these attributes, we are able to represent the image like segmentation, object recognition, and representation and descriptions. The eighth stage, we are able to see the compression. Why the image should be compressed? Storing the image in a local system and you are processing the same image in the local system, it is fine. If you store the image in the central server, I want to access that image from the remote server. So the image will be transferred from one system to another system through the internet. So if you go to transfer an image with high quality, the image size is very high. So the transferring the image from one place to another place in the internet, it becomes very difficult, requires more number of bandwidth. To reduce that, the image can be compressed without without compromising the quality of the image. Without compromising the quality of the image, you should compress and transfer the image. This can be done by different types of image compression algorithm. Finally, we're able to see that the color image processing. Till now, we have discussed about the black and white image or grayscale image. Now we can able to see the color image processing. In this color image processing, we are able to discuss about the three types of color: red, green, and blue. Okay. These are the 9 key stages in digital image processing. Okay. It is an overview. It is an important question. What is my digital image processing? What are the key stages in digital image processing? Okay. So till now we have completed the what is the how digital image processing stages, not the overview of the operations. It is the stages. The next we are going to see about components of the image processing system. The components of the image processing system is how these operations can be done. We have seen the different types of stages now. In the previous slide, we're able to see there is a different types of stages. That is image enhancement, image restoration, morphological processing, segmentation, object recognition, representation and description, image compression, color image processing. Everything will be combined in a one tool. We can call it as a digital image processing software. So now we can to discuss that how the image processing systems will work. Everything will be combined in a single system to perform the image processing. We can call it as a image processing system. Now, We are discussing what are the components will be required in image processing. Here we are able to see that there is here 1, 2, 3, 4, 5, 6, 7, and 8 components are there, including network. So it is a system. Okay, the system consists of the 8 components. First component is nothing but image sensor, where the image can be captured. The next is this image will be converted to the digital image. It This digital image is able to recognize by the computer. So the conversion from the image sensor to the digital image, we requires the hardware, that, or we can call it the specialized image processing hardware. Once the data, this order will convert the image into the digital image, it will be transferred to the computer. Here the computer may be simple, a normal PC, a supercomputer, where it uses the image processing software to process our images. Okay, we can see image processing software. This software is used to perform the operations on the image. The next is mass storage. This mass storage will be div- defined into three types of storage. One we can call it as the temporary storage. Another we can call it as the online storage. The final storage is the permanent storage. We can call it as the archive. Here the temporary storage means when you are processing any image, that image will be loaded into the main memory. So you can be able to process image everything, and we're able to store. Finally, if you store means you go to the storage, the permanent storage. The online is nothing but it is a storage where that image can be viewed online. In online, we are able to perform operation like zoom in, zoom out, rotate, crop, like that. We are able to perform some operations. So mass storage is divided into three types. One is for temporary storage the image for the processing. We can able to process the online image processing. The third one is a permanent storage, we can call it as an archive. The next is display, where the image is displayed on the screen. It may be a flat screen, TV, or monitor. Finally, hot copy. The hot copy is nothing but how the image is transferred into the paper by using a printers. By using the printers. Now, the image will be transferred from one system to the other system by using a network. So the network should consist of a huge bandwidth so that very easily and fastly we can transfer the big size of image from one place to the another place. Okay, these are the components of the image processing system. Simply we can call it as DIP system, that is digital image processing system. The final topic we are going to discuss is applications of the image processing, where this image processing can be used. Where this image processing can be used. We already know that image processing can be used in anywhere. Okay, we can see one by one with a brief discussion. Document handling. Image processing can be used for the document handling. If you go for the bank, it is a signature verification. If you go for the bank, if you give, you are opening the account in the bank, they ask for your signature. If you put the signature will be scanned and stored its database. Whenever if you take the amount from your account through the check, you want to sign in the check. That signature will be checked by the system if the previous signature, whether the signature is matching or not. It can be done by using the image processing applications in the bank. The next is biometrics. We're able to access your biometric information for the passwords. Instead of passwords, we are able to use the biometrics. We can able to scan the thumb or iris or face recognition, or we can use the hand recognition. In our university, we are using the face recognition biometric application. This is an example of the image processing where we are able to start from the camera. The camera will be enough information to the search in the internet and finally tell whether it is present or not. So it will another example, another application of the image processing in biometrics. Another image is object recognition. I already told you, if we capture any image through a digital camera, automatically the software tells that the name of that image. One example. Another one is you're able to capture an image, then automatically the software tells that that particular image consists of how many colors. It is also an example of the image processing. The next is identifying the object in the night way or in the daytime. It can mostly used in defense. It is able to identify an object more than 5 to 6 kilometers away, whether it will be in the daytime or it will be the night time. Okay, this is called the recognition of an image. It is also an application of the image processing. The next is we are able to see the aerial view of the photograph of a place. After taking the photograph, it should be processed according to that user able to understand what is this. That is a top view of this picture. We are able to show the top view and clear, and it is easy to identify the user how the image will be displayed. So another application is the aerial view photography. The next is traffic monitoring. We are able to capture the image for the highly running object. We are able to capture the image of a running object. The vehicle is moving. We want to capture the vehicle and you want to process that image with the clear images so that the image processing also can be used. Okay, in a traffic violation there is a camera will be there. The camera should be capture the vehicle where the vehicle is moving in high speed. While capturing the image will be blurred. You want to convert into the readable image. For that purpose, we are able to use the image processing system. The next is face detection. I already told that according to the face detection, the object should be moved, the camera to be moved according to the face detection. This is also an application which is day-to-day life we are using. In each and every mobile phones, we are able to see that the face detection software is there. If you, on your camera, there is a green color square will be there. While if you're moving your face, that square also moving. This is nothing but face recognition software is installed in your camera applications. Okay. According to this, these are the ways where the image process applications can be used. Mostly it can be used in the medical in it mostly used in the medical very most important. You can see cancer, breast cancer. To identify the cancer cells, the image processing is mostly used. Okay. Previously, if you scan the image will not able to get the cleared image. Nowadays, by using the image processing softwares, the scanned image is more enhanced. Then the image will be sharpened so that we can able to identify the minute pictures so that you're able to identify what type of diseases is here. is a normal morphing. You already know that how the image processing can be used to morphing an image. So these are the applications of the typical applications of the image processing in all the fields. In all the fields. Now I'm sharing the. Now I'm going to share the syllabus. What are the topics we have covered? Okay, this is your syllabus where the first topic we're able to see the introduction to the digital image processing where we have discussed all the topics which are discussed. So here, fundamentals of elements of digital image, what is meant by digital image, how the image will be transferred as the data, pixel, what is the neighborhoods of the pixel, how to find the distance of the pixel, components of the digital image. That is the 9 stages of the digital image components, type of image representation, measures of image, how the pixel can be measured, distance can be measured, application of the digital image processing. So up to this, we have completed module 1. In your e-content, I'm going to post all the PPTs up to 8 units. It will be available from today evening onwards. The attendance marking will be taking some more time. We want to finalize your name, okay, because it is an elective purpose, so they want to finalize the name, so it takes some time to uploading attendance, but the content will be uploaded today including its reference book. So what are the topics, what are the pictures I'm displaying you is taken from the book called Digital Image Processing, written by Richard A. Woods. The publisher is Pearson Education. What are the images I'm showing to you? It taken from this book called Digital Image Processing. Okay. The next is we are seeing about the list of experiments what we have done in the laboratory lecture. The first thing is you want to study of the MATLAB image processing toolkits and various commands. So the first experiment we are discussing about how the MATLAB will be work, what are the various commands can be used in mathematical expressions, plotting. We are able to see, read the image, display the image, as well as the matrix operations also. We have completed this experiment 1. In experiment 2, there is a 3 types of experiments. One is negotiation of the image, converting the image in the negative image. According to the threshold value, the image will be displayed and contrast stretching. Some of the batches we have completed the 2A, some of the batches we have completed 2 and 2B. The one batch will be remaining, you should be completed the entire thing. So from this weekend, we are able to complete this experiment also. Okay. Up to this, I'm concluding that chapter 1 is completed. In your laboratory lecture, the first experiment is completed. In second, 25% is completed. The remaining will be seen in the consecutive classes. Okay. Okay, fine. Now, I'm requesting everybody can share your enrollment number or the attendance with your class name. From tomorrow, we are going to discuss about the unit 2. You want to drop your attendance with your class name. Those who are given the attendance, they can leave the class.
Hello, sir.
Yes, ma'am.
So, do you have any ebook with you?
Yes, yes, yes.
Will you
I'll be
upload that
sharing.
in the contents too?
Yes, yes. I told no. The image processing by Richard E. Woods. I have that book. I'll be shared with you in e-content.
Yes, sir. Actually, I'm currently not in our country, India. I'm the one who got the scholarship to be in Romania. So
Okay,
it is
fine.
like always not due to the time difference. It is not possible to take all the lectures always because it's like 3 hours difference from we are early from India.
Okay, fine. Okay, in
So
this regard, just you can drop me an mail. I'll be
yes,
sharing
sir.
all the contents. We can drop a mail to me. I'll be share all the PPTs and ebook and the programs to you.
Definitely, sir. Sure. By today itself, I will drop you a mail to you.
Yeah, yeah. Once if you drop the mail, I'll be reply with all the contents for your reference. Okay.
Okay, sir. Thank you. Thank you so much.
Thank you, ma'am. Thank you.